So, good evening, guys. How are you? I hope you are fine. So, today we will study about organic chemistry. So, why I'm here? Uh, because if you are targeting your 11th, 12th, or beyond that, like JE NEET, so you are on the right track and even on the right platform. So, firstly, I have to introduce myself. Myself, Saraf Juria. I am currently pursuing my masters from ICT Mumbai. I have qualified IIT JAM, CUAT, ICT Mumbai exam itself, IACS Kolkata with good rank, and gave interviews at IISER Kolkata and IACS Kolkata, and also selected by IITs. So this is my qualification. So today I am going to teach you about organic chemistry. So students always facing difficulty in organic chemistry. They always have a fear, like we can't do organic chemistry because they never go with the basics. So basics are very important. It's not like that you know something about one concept in the organic chemistry and you can do the reaction. So organic is all interrelated. So I have chosen one topic like electrophiles and nucleophiles. So the question arises like why should I choose this topic electrophile and nucleophiles? Because these are the basic fundamental what I can tool that can help to tackle the big reactions that we'll see later. So actually this is the very very basic concept. Just like without chemical bonding, without periodicity, you can't understand a single step in the chemistry. In the same way, in organic, if you want to understand organic, you must know about the reactions related to electrophiles and nucleophiles. I bet you every reaction, even 90% of reaction in the organic chemistry are through electrophiles and nucleophiles. If you go ahead, you might have heard about Finkelstein reaction, Sandmer reaction, Gatterman-Koch reaction, aldol reaction, that very famous reaction, aldol, Cannizzaro. So these all our reactions are related to electrophiles and nucleophiles. So that's why I choose this topic, electrophile and nucleophile, as a demo lecture. So without wasting time, let us go and understand what are electrophiles and what are nucleophiles. In general organic reactions, we have seen this like we have substrate and we had reagent and we got the product. So this is the simple organic reaction. So these reagents can be electrophiles or nucleophiles. So first let us understand the word electrophile. As the word itself indicates that electrophile, it is comprises of two words, electro and phile. What do you mean by electro? Electro is something like electron, and phile means loving. One who loves the electron is electrophile. Similarly, it goes with the nucleophile. What is nucleophile? It comprises of the two words nucleo and phile. Nucleus, loving. So these are the basics. What I can say, the etymological meaning of that these two words, electrophiles and the nucleophiles. It is mentioned here like electro means electron and phile means loving. So it is represented by E positive because they are electrophilic, means they love electrons, so they are denoted as E positive, and nucleophiles are denoted as Nu minus. So these are the definitions, like any molecule, atom or ion that is deficient in electron. So for what are the conditions for any molecule to be an act as electrophiles? So there are generally two conditions, like what are electrophiles? Electrophile, the words itself says like electron loving, so it must have electron deficient. These are the electron deficient species, definitely. The word itself says these are the electron deficient species. And what we have heard in our previous, what I can say, in the class 10th, class 9th, what are electron deficient species? That do not have your octet, complete octet. They have less electrons than their octet, less than 8 electrons. So they are considered as electrophiles. So I am telling you that electrophiles are the species that accept electron, that loves electron, that are electron deficient, that loves electron, that they accept electron. So for accepting the electron, they must have vacant orbital. So these are the two conditions for a molecule to act as an electrophile. First is they have electrons less than 8, and second they must have vacant orbital. So I am talking about vacant orbital. They can be bonding, they can be anti-bonding. We will see it later with the examples also. So it is mentioned here like these are the positive charge species. They are generally positive charge, or they can be neutral also. We can see the examples also ki what are the neutral electrophiles. Okay, so electrophiles are also called Lewis acids. So in our basics, in our class 9, class 10, we have might have heard about Arrhenius concept of acidity, Bronsted concept of acidity, and the last one is the Lewis concept of acidity. And what he said about what Lewis said about acidity, Lewis said the species that accept the electron pair is called an acid. Which can accept the electron pair is called an acid. So this is exactly like same. Electrophile are also the same, that accept the electron, that are electron deficient. So these are electrophiles. So electrophiles can be categorized in the following groups. They can be positive electrophiles, they can be neutral electrophiles. So what are positively charged electrophiles? The species that are electrophiles and having the positive charge. What species are electrophiles? That have electrons less than 8 and have a vacant orbital. Okay, so these are the electrophiles. So positive charge electrophiles, there are example of electrophiles like we can the simple example, the basic example is a proton. Proton is H positive, it has a vacant orbital, that is 1s orbital. So the proton itself act as an electrophile. So like they have given the examples like SO3H and no positive H. Have you ever seen this SO3H? Yes, you can see if you did sulfonations in your whatever I can say, in your 11th, in your 10th, then you can have seen this electrophile SO3H that is formed by the autoprotonation of H2SO4. When two H2SO4 combines, it forms SO3H positive. We will see it later when we go towards the reactions, but you have might ever seen this. NO positive, NO2 positive, X positive, R positive. What is this? This is something disonium. You will see it later in the maybe in the Sandmeyer reaction. You will see this disonium. CS3 positive, that is simple or carbocation. So these are the positively charged electrophiles. So there can be also neutral charged electrophiles. How? Any species that have an electron less than 8 and have a vacant orbital act as electrophile. It can be positive charge, it can be vacant, it can be neutral, so it doesn't matter. So we'll see the examples. So the Lewis acids, all the Lewis acids act as a neutral electrophiles. How they are act as a neutral electrophile? If we talk about this BF3, if you see this compound BF3, so boron has 6 electrons. So it does not have 8 electrons. So it has electrons less than 8. Firstly, first condition is satisfied. And what is the second condition? That condition is the availability of the vacant orbital. As we see this BF3, in BF3 the boron is sp2 hybridized and there is one vacant orbital is present. So it is also act as an electrophile. We will see it later when we make its chemical its structure, then we will definitely got big clarity. So these are the electrophiles. So there are also the neutral electrophiles in which the pi bond is present, like in carbonyl. You might have ever seen like addition of any nucleophile in the carbonyl group. So how it happens? Because the carbonyl, in carbonyl, like if I can talk about this C double bond O, so oxygen is more electronegative than carbon. So what it did, it abstract the electron density from the carbon. So there is a formation of delta positive charge on the carbon that make it electrophilic. So the nucleophile can easily attack on the carbon, and hence the easily attack on the carbon, uh, and the electron will go on the oxygen. This acyl chloride is also act as an electrophile. So why it act as an electrophile? Uh, uh, why it's act, uh, wait for a while. So why it acts as an electrophile? Because here also the carbonyl in carbonyl group, the carbon is electrophilic in nature. It is also as an electrophile. So this ICl, this is interhalogen compound. This is also act as an electrophile because of the sigma star. I will tell you later when we go through about these reactions. Okay. So there are the positive charge electrophiles in which we can see this tertiary cation, this secondary cation, primary cation. What are tertiary cations? Tertiary cations are the cations in which the carbon is attached with the three R groups. These R groups can be anything. When carbon is directly attached with directly three carbons, then it is tertiary. When the carbon that bears the positive charge is attached with the two carbons more, then it is secondary. When the carbon that bears a positive charge is attached only to the one carbon, then it is primary. And when the carbon that bears a positive charge doesn't attach with any single carbon, then it is methyl, simple methyl. So like this, so I am telling about this like bf3. In the bf3, like it is mentioned here, like if you can see that boron, so boron has so you can see this boron, this you can see this boron has 6 electron is in its vacant orbital and have a vacant in its vacant valence shell, and have a vacant orbital, that is p orbital definitely. So it has an electrophile. So these are the examples of the electrophiles. So why this carbon dioxide is electrophilic in nature? So this is electrophilic because if you can make the resonance structure, like it is mentioned here, if you can make the resonance structure, you can easily saw this carbon is electrophilic in nature, because the carbon will get positive charge in resonating structure. So that's why it is electrophilic in nature. So now we are moving towards, we will see the more towards the electrophiles. Okay. So what is this, what are the strength of electrophiles? So I already told you what are electrophiles: the electron loving species, the electron deficient species. So which is more electrophilic? That is more electron deficient. The species which is more electron deficient is more strength, that has the more strength of being an electrophile. So the strength of electrophile is given by its electrophilicity, which is the ability to attract electrons. If someone needs more electron, means it is more electrophilic. Okay. So if you can see this example in benzene and chlorine is an electrophile. Benzene act as a nucleophile and chlorine is act as electrophile. I told you about nucleophiles. I only told you about electrophiles. So you can see this is an electrophile. So this is nucleophile. I'll tell you later. This is nucleophile. Nucleophile will attack on the this electrophile, and we got this chlorobenzene. This is benzene. This is called chlorine. So benzene acts as a nucleophile. Chlorine acts as a electrophile. Why it acts as electrophile? Because it has a positive charge and hence has also the vacant p orbitals, or we can say the d orbitals are also vacant. So this is act as an electrophile. So this electrophile, a species that is electrophilic in nature, can show two type of reactions. It can show either electrophilic substitution reactions or electrophilic addition reactions. So this is electrophilic substitution reaction. Why it is electrophilic substitution reaction? Because what do you mean by substitution? One is going inside and one is going outside simultaneously. So here the chlorine will attack on the this benzene, and this H positive will leave. So one electrophile in, one electrophile is out. So this is electrophilic substitution reaction. It can also show electrophilic addition reaction. What do you mean by electrophilic addition? This is the addition to pi bonds. If there is alkene and it donates its electron to the electrophile, so one carbon will get positive charge, and then the nucleophile attack on that positive charge. So this is a type of electrophilic addition reaction. In this, the electrophile is added on that double bond, so that's why it is called electrophilic addition reaction. Okay. So it is mentioned here, although the hydrogen ions has a positive charge, it doesn't qualify an electrophile since it has a vacant orbital in its outermost shell. Why H positive is act as electrophile? H positive, it has a positive charge. I know why it has a positive charge, but it is almost neutral. It doesn't have less electrons than 6 because it has a duplet like structure. Hydrogen always has to fulfill its duplet, so it loses its electron. Then why it's act as electrophile? Because it has a vacant orbital. That's why it's act as a electrophile. Okay. So we will see nucleophiles. So in the same contrast as the electrophiles are the species that are electron loving, or I can say electron deficient species. In the same way, what do you mean by word nucleophile? Nucleophile is something nucleus loving. What do you mean by nucleus loving? Nucleus, what is the charge in the nucleus? So there is a positive charge. So I can easily say this statement that the species that loves the positive charge. What do you mean by love positive charge? I can say in the another language that can easily donate electrons, that are electron rich species, that want to donate his electrons. They love positive charge, and they love positive species like nucleus loving, positive charge loving. So these are the electron donating species. So it is mentioned a nucleophile is a reactant which gives an electron pair to form a covalent bond that donates electron, I can say. So these, they can be either negatively charged or it can be either neutral. Why it not be positively charged? Because if a species already have a positive charge, how can it donate its electron? Because what do you mean by positive charge? It is electron deficient. What do you mean by nucleophile? It have to donate electrons. If a species has already have a positive charge, how can it donate its electron? It is already donated now. So how can it donate electrons? So for a species to act as a nucleophile, it can be negatively charged or it can be neutral also. We will see this. Like we can see this chloride ion. Chloride has, so I can tell you what are the two conditions. What are the two conditions for an species to act as a nucleophile? So what about electrophiles? We know what is electrophiles. What are the condition of electrophiles? A species must have electrons less than 8. And what is the second condition? It must have a vacant orbital. Okay. So what are the condition to be a nucleophile? For a nucleophile, the species must have 8 electrons. And what is the second condition? It can have either lone pairs, it can have either pi bonds. So the donation can be possible by these two. Why it must have these 8 electrons? Because for a species to donate electrons, like I have to donate electrons, what is the first requirement? I should have be fulfilled from myself. So I should be fulfilled myself, then I will donate. Like if you can understand like this, if I have to donate, I have to do charity. So what is the basic requirement? Like I am happy in my family, I have good income, I have like that. Okay, if I have good income, then I can go for charity. If I don't have money to eat, then how can I go for charity? So this is not possible. Similarly, this is the same case in the nucleophiles. For a molecule to act as a nucleophile, it must have its complete octet along with the lone pair or pi bonds. It can be lone pairs or it can be pi bonds. So you can see the species like this chloride. It has vacant. It has a complete octet. Why? Because we know this chlorine has the 17 electrons, and with the negative charge it got 18 electrons. So it has a full octet complete, and it has a lone pair also. So that's why it act as a nucleophile. Similarly, this chloride, bromide, iodide, hydroxide, alkoxide, azide, carboxylate, cyanide. So these all act as a nucleophile. I told you the conditions. What are the conditions? So they already fulfill that conditions. That's why I am telling that these species are nucleophiles. So in the same scenario, like I told you that all Lewis acids are electrophiles, because that Lewis gave the concept like the species that have a vacant orbital, that have a that can accept the electron pair are Lewis acid. Similarly, the all the nucleophiles are acted as Lewis bases, because what are the Lewis bases according to Lewis? What are Lewis bases? The species that donate electrons. Similarly, I can say that all Lewis bases which contains the lone pairs are act as a nucleophile. Just like we can see this thiol, water, alcohol, what is this, H2S gas, disulfide, sulfide, and ammonia. But ambident nucleophile. What do you mean by this word ambident? Ambident means that have more than one centers of donating, more than one donating center. So these are ambident ligand. These are more than one centers of donating the electrons. Just like if you can ever see the enolate ion, this is the enolate ion. If we did the resonance in enolate ion, in enolate itself, what do you mean by enolate? Enolate, if enolate did the resonance, in enolate the negative charge in the carbon, so carbon act as a nucleophile. But if we did the resonance, that electrons will go towards the oxygen. Now the oxygen get the lone pair negative charge. So how we can decide that who is going to donate the electrons? So there is a two centers in which the negative charge is present, in which the both atoms can be act as a nucleus. So both atom can donate as a can donate electrons, because I already told you that what are the conditions, like it must have octet complete and it must have a lone pair or other pi bond. So they both can act as a nucleophile. So these are the ambident nucleophiles which have more than one nucleophilic center. So these are the ambident nucleophiles. So these are the ambident nucleophiles. So there are ambiphiles. Ambiphiles is something which have both centers, like electrophilic center also or nucleophilic center also. Like if we can see the cyanide, that this is acetonitrile. In acetonitrile, the carbon will act as electrophilic center, and nitrogen will act as a nucleophilic center. Why carbon is act as a electrophilic center? Because I already told you, like in carbonyls. If you remember about carbonyls, I told you that carbonyl will act as electrophile. Why? Because in carbonyl the carbon gets a partial positive charge because it is attached to the highly electronegative element. So there is a partial positive charge. So there is an attack in the pi star. I'll tell you later when I go in the deep now. I'll told you everything about what is exactly pi star, what is exactly sigma star. In the same way, this if you see this acetonitrile, this carbon will act as a electrophilic center, and definitely the nitrogen will act as a nucleophile. Why nitrogen is act as a nucleophile? Because nitrogen has a complete octet and has a lone pair. So lone pair is mentioned here, not mentioned here, but is a lone pair. Okay, so this is all about nucleophiles. So what is the factors that affect the nucleophilicity? So that's the first is the charge. So we always tell that charged nucleophile are more effective, they have more nucleophilicity than the neutral ones, because the charged molecules are highly unstable. Why? All the charged molecules in the universe are unstable because they have to follow the electron neutrality principle. The species that are neutral, that are stable, and the species that are charged are not stable. Why they are not stable? Because they are high in energy. If something is high in energy, that means it has a lower stability. If they have lower stability, means they have high reactivity. So that's why if I made the conjugate base of this, like if I made the conjugate base of H2O, what will be its conjugate base? Definitely hydroxide ion. So in hydroxide ion, this is more nucleophilic than the H2O, simple neutral molecule. Why? Because this is charged species which is less stable, means which is more reactive, so it will react easily. So that's why it is more nucleophilic. Similarly, in the ammonia, if I made the conjugate base, that is nothing but the amide. So this is a very good base. You might have ever heard about this amide. This is very strong basic, like sodium amide, that can even form benzene intermediate, if you have ever heard. So it is that much basic. So like hydrogen sulfide may form as such. So similarly, so these like carboxylic acid, this is not that much basic, but if you make this not that much nucleophilic, but if you make this carboxylate ion, so this is more nucleophilic. Why? This is carbon has a negative charge. Similarly, this phenol and phenoxide ion, phenoxide is more nucleophilic. So this is so, and the second factor, size or steric hindrance. So in nucleophilicity, nucleophile have to attack on the electrophilic center, because the what is the reaction? In reaction, the nucleophile will attack on the electrophile. Why? Because electron always move from the higher concentration to the lower concentration. This cannot be happen that the electrophile will attack on the nucleophile. No, always nucleophile will attack on the electrophile. So that for the, because nucleophile have to attack, so it must be in small size. Why? Because if it is bulkier, so it is hard to attack. Why? Because there will be a steric hindrance. What do you mean by steric hindrance? Steric hindrance is the repulsion due to the big groups. Because if there are two big groups and they are colliding, they are close to each other, so there will be a repulsion, and if there will be a repulsion, there will be the instability. So that's why for a good nucleophile, it must be a small in size. We'll go into detail if we go towards a reaction. We will see. If we can talk about like this is ethoxide, this is methoxide. So methoxide is a good best nucleophile. Why it's best nucleophile? Because it is small in size. Just like if you can say like this is a tertiary butoxide and this is the isopropoxide. So this isopropoxide is the more basic and more nucleophilic than the tertiary butoxide. So about nucleophilicity, because nucleophile have to attack on the electrophilic center. So it, the smaller it will be, it can more easily the attack will be possible. So there is a easily attack for the isopropoxide than the tertiary butoxide. So if we talk about the steric hindrance, so this is the molecule, this is the tertiary butanol. If I am talking about the tertiary butanol and the methanol, so I am clear, like for a molecule, for to act as a nucleophile, the best nucleophile is the nucleophile that has a lone pair and has a small in size. So that is the good. Like if we can talk about, like you can see the bulkiness of this 3 CS3 bonds. So these three CH3 molecules, so these 3 CH3 are highly crowded, so it is hard for the oxygen to attack on the electrophilic center. So that's why this methanol is a good nucleophile than this tertiary butanol. So yeah, this electron activity also affects the nucleophilicity. Why? Because what are the nucleophiles? Nucleophiles are the something, that species that donates its electron. So for a species to donate its electron, it must, there is a one concept in organic, or what I can say in the chemistry, electron activity. What is electron activity? It is the ability to attract the shared pair of electron. The more the ability of the element, the more it can hold the electron towards itself. Okay, like what I can say, if I'm talking about the, we know that the fluorine is the highest electronegative element in the whole periodic table. So fluorine has the high electron activity. If it is highly electronegative, then it means it is less prone to give its electrons. So means it is less nucleophilic, because for to being a nucleophile, you must have to donate electrons. If you don't donate electrons, so means you are less nucleophilic. Even you have a lone pairs, even you have a vacant, you have a complete octet, but it must like it must be there, like you have a less electronegativity. Just if I can see, like this is what I can say, like if I made the conjugate base of the like methane, so it is CS3. If I make the conjugate base of ammonia, that is amide, then is hydroxide, then if that is fluoride. So carbon has the less electronegativity. So less electronegativity, so less electrons are towards the nucleus, so it can easily donate the electrons. So that's why the along the period the nucleophilicity will decrease. Why it will decrease? Because the electronegativity of the element increases. If electronegativity increases, electrons are towards the element, it never donate electron. So that's why the CS3, that is methyl is more highly, what I can say, the highly nucleophilic in nature, then followed by amide, followed by hydroxide, followed by fluoride. So these are there. So definitely there are the so there are also mentioned the solvents. Solvents also plays a very important role, because like in electrophilic reaction, in electrophile section, we saw like what are the reaction involving the electrophiles, that are electrophilic substitution reactions, and second one is electrophilic addition reaction. Similarly here the nucleophilic substitution reaction takes place. So in that reaction the solvent plays a very very important role. Somewhere the protic solvents are used, somewhere the aprotic solvents are used. If you have ever heard about SN1 SN2 type of reaction, you have some idea, like in SN1 we take the polar protic solvents, and in SN2 we take the polar aprotic solvents. So why this is like that? So we will go into detail, but now we never go into detail, because we have only introduction about electrophiles and nucleophiles. So this is the part. So this is about the solvent part, how solvent affects the reactivity. If you change the solvent, maybe there the pathway will change, maybe the SN1 will go to the S2 SN2, or SN2 go into the S1 SN1. So solvent equally plays an important role in the organic reactions. So these are the solvents. So yeah, there is a one more effect like resonance. If there is a resonance, so what I'm going to try to say, if there is a resonance, there is a less availability of the lone pair. So what I'm trying to say, I'll explain. Like if I have alkoxide ion like RCS2O minus, and if I have a carboxylate ion, this RC bond O minus. So here if you can see, the oxygen lone pairs are delocalized. If the lone pair are delocalized, means they are less available to donate. If they are less available to donate, means their nucleophilicity is less. That's the reason we can say that the phenols are more that the alcohols are more nucleophilic than the phenols, because in phenols the lone pairs are involved in the what I can say, in the resonance. If lone pairs are involved, so how can they donate? How can they donate? So that's why the if the resonance increases, the delocalization increases, the nucleophilicity will decrease. Here if you can see the example like amine, so this is amine, this is amide. If you can see in amine the nitrogen lone pairs are localized, because there is no delocalization. Here in the amide, the nitrogen lone pairs are delocalized towards the oxygen, so they are less available on the nitrogen, means the nucleophilicity will decrease. So this is the basic difference uh, uh, what we have studied so far. So what are electrophiles? They are also called Lewis acids, and they can be positive or neutral. They undergo nucleophilic addition and nucleophilic substitution reactions. I already told you these are electron deficient species. They can accept, because the what are electrophiles? They have to accept the electron pair. So all carbohydrate and the electrophiles represented by E positive. Examples are the molecules that have a positive charge and have a vacant orbital is electrophiles. Similarly with the nucleophiles, they are the Lewis bases. They are negative charge or neutral. They can undergo nucleophilic reactions and nucleophilic substitution reactions. They are electron rich, and definitely they have an electron pair to donate. They represented by Nu positive. Example are chloride, methyl, carbonyl. This is all about electrophiles and nucleophiles. So this is what I can say. This is the very basics of organic chemistry, because without this electrophile and nucleophile concept, I don't know whether you can handle the reactions even in class 11 or 12. You can't handle, because these are very basics. With this you can handle big problems. It is easy for you to tackle organic chemistry with this electrophile and nucleophile concept. I hope firstly I want to get to know, like what is your expectations of this one time interaction, मतलब one to one interaction program. If you want to learn more, if you want to want to get a dedicated organic course, please give a feedback uh, in our published house, like whatever we have publication like Vedantu. So please give a genuine feedback because it's very important for us, because it helps to improve our skills, our requirements, like what we have to do next, what we can give best for you. Um if you want to target this JE NEET, so this will be very beneficial for you, because I assured you, if you have fear in organic chemistry, after that, after this course, you will never feel like I am feeling this problem. I saw this question and I got scared. You will never feel like that. You will always be happy. You will always feel like, okay, if it's organic and it will be fun. So if you need any mentorship about how you can prepare, how you can start with these basics, you can definitely approach from this platform Vedantu. So please let me know how is the session, how you're feeling right now. Are you feeling like you have gained something, you have learned something? If this is you can rate this. So this is you can give the feedback. So this is very important for us. So uh, we'll meet in the next session. So uh, goodbye, take care, thank you.